Question about duck. So here we have basically two objects. First one is stone. Let's say initial velocity for the stone v1, and this is the direction alpha. This is our horizontal surface, ground. And the second object is somewhere here at some height. We have a duck, second object. It's moving, flying with constant velocity. Let's call it v2. And from the given of the problem, stone was thrown directly to the duck, but somehow stone still hits the duck, because we know that stone cannot fly in straight line, yes, because we have a gravity, and it will slow down upward and it will come back to the earth. That's why stone will change its direction. I don't know, for example, like this, and somehow it will meet with the duck. So this is what is given. So we should find at what height the duck was flying. Yes, duck's velocity is constant. It means for duck we can write only one equation. So this is the distance that duck travels. Let's call it x2, and x2 equal to velocity of the speed of the duck times time. Yes, this is time traveled from this point to this point. During the same time, stone travels from here till here. Yes. For duck we finished. For duck we have only one equation, because velocity is constant, very simple. But for stone, stone moves under influence of gravity. In vertical direction it moves with constant acceleration. In horizontal direction it moves with constant velocity. So as usual, let's identify our direction, axis direction. Here y upward, x direction to the right. Here we have a zero position, yes, for both x and y components. This is a horizontal distance that stone needs to travel. Let's call it x1. Yes, and x1, of course, equal to horizontal component of the stone, which is always constant. Yes, v1 times cosine alpha times time. Let it be equation number 2. And now let's come to the vertical component. Now for vertical component, as you know, we can write 3 equations, but let's think a little bit which one might be more useful, let's say. So in this equation we should have information about time, because everywhere we have a time, and there should be information about height. Yes, so I think this one will be useful. Height, which is final position minus initial position in vertical direction, of course, equal to initial velocity in vertical direction, v1 sine times time, minus, because of gravity, time square. This is equation number 3. So we have 3 equations, so we should think, do we have enough equations? So how many unknowns we have? x2, x1, time, and h. So I counted 4 unknowns, but we have 3 equations. So likely we cannot finish with these 3 equations. So we need one more equation. So what kind of equation we are missing? So logically, let's think. We have a time everywhere. Yeah, in all equations we have a time, so we don't need likely equation related to the time, because we have a time everywhere. x2, we have x2 only in one equation, x1 only in one equation, h is only in one equation. So it's a problem actually, because we cannot use x2 anymore, because we don't have it in other equations. Same for x1, same for h. So it means I think next equation should be related to x1, x2, and h. I will draw this kind of triangle, right triangle. So pay attention to this right triangle. Here we have a 90 degree, and this side is h, this side equal to x1 minus x2, yes. So I see a relationship between h and x1 minus x2, because tangent alpha equal to opposite side divided by this adjacent, yes. So this I think will be our next equation. So tangent alpha equal to h over x1 minus x2. This is our equation number 4, and I hope these 4 equations will be enough to solve this problem. Further is just total math, so just follow. So from equation number 4, I will continue equation number 4. So h equal to tangent alpha times x2. So let me bring h, x1, x2 and use it here, substitute into this equation. This is h equal to tangent alpha times x1 minus x2. This is x1, equation number 2, minus x2, equation number 1. As you see, we have a time everywhere. We can cancel them. So we have an unknown t. We can first of all find time, then come back to the equation number 3 and calculate height. So v1 minus, I will open the bracket, gt. So if you pay attention, this part will be equal to sine alpha, so we can remove this part, and from here it's obvious that time equal to 2v2 tangent alpha divided by gravity. So this is the time. This is the time flight, let's say, yes. Now we can come back to the equation number 3 and calculate height. So physics part finished. We finished physics part. So first is just calculation. So this is equation number 3. I will substitute time in general form, v1 sine alpha t square. So let's continue. This is the time. Here time square. G square. So we can remove one of the gravity. We can remove 2 and 4. We can take out of the bracket, for example, 2. We can take v2, one of the v2, one of the tangent alpha, and 1 gravity. Yes. So I'm simplifying basically. So at this side we have a v1 sine alpha minus v2 and 1 tangent alpha. Yes. Okay. Yeah, this is the final answer. We can also take sine out of the bracket, I think, but let's keep it like this. So this is the final answer for the height of the duck.